Hey guys, welcome to lesson 712, day 1. Our goal for today is to construct the sine table. Okay, so the table representing the sine function. So the way we're going to do that is by visualizing this ride. All right, so it's a ride called the Screamer, and you can read this description about it. It's supposed to be terrifying, and basically it's an enormous wheel, okay? And it, like, half of it is underground and the other half is above ground, and you start by getting on at ground level. So I got like a little picture here so that you can try to visualize what's going on. And it says that it has a radius of 100, but we're just going to go ahead and change that to a radius of 1 to make our lives easier. It'll make more sense later on why we did that, but for now we're just going to go ahead and go with the radius of 1. So the bottom half of the wheel, it's in these dark, murky waters and, spider webs and stuff. So basically what you're going to do is you get on the ride right here at position number 1 on the ground, and then it rotates you over super fast, super fun. And then once you get here, you dip underground. It's terrifying. You continue rotating, and then you get back to ground level and get off the ride or go again, I don't know. So basically, our job is to figure out how to find the height at each position. Each of these boxes is a position, and we want to know how far vertically are you from the ground at that particular position. So let's say we are first going to talk about position 2. So at position 2, I'm going to go ahead and do a little drawing here. I can create a triangle. Okay, here's my line leading to position 2, and I'm just going to go ahead and make a right triangle. Hopefully, with all the right triangle review we've done lately, this will not come as a surprise to you. So this is my right triangle here, and there's a couple of pieces of information that I do know about this triangle. Okay, for starters, since the radius of this wheel we said was 1, all of these spokes that go out from the center to the edge of the circle, they're all length 1. So we know that the hypotenuse of this triangle is a 1. All right, and then we also know that we're trying to find the vertical height off the ground. Now this line right here is the ground, so this side is what's going to represent that vertical height. That's what we want to find. So I'm going to go ahead and make a little prototype here of this triangle so that we can do some work on it. Now, we also need to know what this angle is. If we go to the next page, I have a table here that says all of the angles at all of the positions of cars. So we're starting at 15. Because car number 2 is 15 degrees of a rotation. So we know that this angle right here is 15 degrees. Okay, so we're going to go ahead and put all that information on my little work triangle here. And now we want to solve for y. So hopefully you remember from last week when we were doing right triangle trig, this is where our SOHCAHTOA stuff comes in. All right. So you would start the same way as we started last week, as we learned. Label the sides O, A, or H. So 1 is going to be the longest side. It's the hypotenuse. So we're going to go ahead and label that with an H. And the Y is going to be an O because it's the opposite. It's the farthest away from this angle. So that's how we know. So because we're working with O and H, we are going to be using sine. And I mean, that's probably something that was already given away by the fact that we know the goal of this lesson is to work with the sine function. So we can start setting it up just as we are used to. Sine of 15 over 1 equals y over 1. Now, because these are just ones, we can definitely, cross multiply as usual, but it becomes like a situation where we don't actually have to do all that work. And that's why we chose our radius to be 1. Okay, it's literally just going to make our life so much easier. So you end up with y times 1, which is just y, and then sine of 15 times 1, which is just sine of 15. So what ends up happening here is that the height that we're looking for is literally just the sine of the angle. So keeping that in mind, you just want to pull up your calculator and then you can just go ahead and type what you see. So we're going to calculate the sine of 15. My calculator would turn on. Okay, so sine of 15. Type it in. Also make sure that your calculator is in degree. If your calculator is in radian mode, you want to go over here into the mode button and make sure to change that. Make sure degree is highlighted. But once you do sine of 15, you should get this decimal. We'll go ahead and round that to about 0.259. So we'll say that our height is about 0.259. All right, so this tells us that at position 2, our rider is going to be 0.259 feet off the ground. Obviously, we're talking about a really mini version of this wheel with the tiny radius, but that's how that would work. Okay, so let's try another one. Now we're going to go ahead and do position 10. So I'm going to go ahead and erase what I've drawn here so far and make a new drawing. All right. So at position 10, we'll make it red. Position 10 is over here, so we'll draw the line from the center to that position, and the triangle that we draw is always going to be with the ground. So we're going to bring that straight down to ground level and then complete our triangle. Oops. All right, so back to labeling this with the information we know, and also I'm going to go ahead and make my prototype version for us to work with. And now we can go ahead and label the information that we know about this triangle. So we know that this part right here, because it's another radius, we will label it with a 1, and that's our hypotenuse. And then we also know that we're looking for that vertical height off the ground. That's going to be this side, so that's going to be our y. And we need to check what that angle is. So at position 10, we go to our table. Position 10 is an angle of 135 degrees. So here's the thing about that. That tells us that from the start to this position, we have rotated 135 degrees. So in fact, this angle right over here is 135 degrees. However, that isn't the same angle as what's in our triangle. Okay, we have to do a little bit of math to find this angle. So we know that an entire full revolution around the whole circle is a 360 degree turn. Hopefully you remember that from geometry. And so halfway brings us to the 180 mark. Okay, halfway through the revolution, we are at 180 degrees. So if I rotated 135 degrees and my triangle, the angle that I'm using is between the 135 and 180 point, that tells us that to find this angle, we need to go ahead and do 180 minus 135. So this is going to give us a 45 degree angle. Okay, so we know to put 45 degrees in there. All right, so now we can go ahead and do exactly what we did the last time, but this time it'll save us some work, right? We know we just need to take the sine of our angle. So sine of 45. And that's going to be, let's find out, 0.707. So y is about 0.707. So that's the distance off the ground this time. Okay. So now we can go on to our next example. I'm going to, again, erase my stuff here. I'm sorry for the background noise that you guys probably all heard. My roommate came home and made a lot of noise. But anyway. So next, we want to know the height of a car in position 15. And actually, you know what, before I do that, I want to go back to my table and go ahead and update these numbers. So 0.259 was this one. 0.707 was this one. And this column is for the angle inside the triangle. So ours ended up being 45 degrees, so that's why that's there. All right, so let's go ahead and do our next example now. What's the height of a car in position 15? So let's go ahead and draw my new triangle and my line tool. Okay, position 15 is right over here, out to the center, and then again, we always want to make our triangle with the ground. So now I'm going to bring my height upwards, since now position 15 is underground. That's the scary portion of the ride. All right, so I'm going to make my mini one down here as well. All right, so let's see what we know about this triangle. It's position 15, so, oops. It's position 15, so we know that position 15 has a 210 degree angle. So let's go ahead and go back and figure this out. So that tells us that from here, from here all the way to here, not what I wanted, is 210 degrees. Guys, I am struggling. All right, so we need to figure out, again, what that angle is inside of my triangle, because it's not 210. We can do that by realizing that this angle right over here is 180, and ours passed 180 to get to 210. So we can figure out that angle by doing 210 minus 180 for an answer of 30 degrees. So I know that this angle is 30 degrees. And of course I know this is y and this is 1 as always. So the sine of 30, we're going to put that in our calculator, and we get 0.5. But here's the thing. With sine, we want to take direction into consideration. So the thing is, this position is underground. And because it's underground, we need to make it negative. So really, we want negative 0.5 to be our answer. Now, what I want to show you is that if I had just taken the sine of the original angle that we started with, you actually do get that negative 0.5. So the calculator knows about that underground angle, and it tells you right off the bat that 210 is going to be negative. All right, one more example here. What is the height of a car in position 23? So let me go ahead and erase my stuff. I'm going to pause recording because I'm running out of time. All right, I've started my drawing for position 23. Let's go ahead and make the rest of our triangle up to the ground, finish it, and we'll make my mini version here. All right. So now let's label what we know about this triangle. We know that the hypotenuse is 1. We know we're trying to find this height right over here. And what's the angle that we need to figure out? So we go to our table and look at position 23. Position 23 is 330 degrees. So that tells us that from here all the way to here is 330 degrees. Okay, so this actual angle inside isn't 330, but we know that the whole revolution is 360, right? One whole revolution. And if we stopped at 330, that means this space in between is going to be the difference between those two. So that tells us we're dealing with a 30-degree angle. All right, so now I can just use the sine of 30 for this one as well. So we know from this problem that we get 0.5, but because this one is also underground, this is going to be a negative 0.5 as well. All right. And that's about it. I do just want to mention a couple of things here. There are positions where you can't really make a triangle on this picture. So like right over here at ground level at 180 and 360, or this is also 0 degrees as well. Those would have heights of 0, right? Because they're literally on the ground. Whereas if you go up here to 90 degrees, since this is a radius, this is a perfectly straight up and down radius length, it would be 1. Because remember our radius we said was 1. And then likewise down here when we're directly below, it's still going to be 1, but because we're underground, this one is going to be negative 1. All right, so those ones are just slightly